Yeah, hello. Yeah, can you able to listen? Hello, can you able to see me? Anybody can able to respond this? Yeah, hello. Nitish, Raghavan, Hariharan. Hariharan, are you there?
Yes, sir.
Yes, sir. Yeah, okay. Guys, can you able to see me? Vishwaragul, Hari Vignesh, Divya. Yeah, guys, can you able to see me?
Yes, sir.
Yeah, okay. Okay, guys, so let us start the session. Okay, how many of you have gone through this unit one? What I uploaded in Google Classroom? Have you all gone through that? Yeah, guys, please respond. Divya, can you able to hear me? Yeah, yeah, I'm there. Yeah, can you able to see me there? Yeah, I could able to see someone, but I could be able. Yeah, you are E and A, right? Yeah, yeah, okay. Yeah, okay, okay. Yeah, you have. If you have any doubts, you can ask me under Unit One. I've posted all the materials in Google Classroom. In Google Classroom, especially all the units has been posted from Unit One to Unit Five. For particularly for Unit One, I uploaded video lectures. In those video lectures, there will be so many snippets. Okay, so kindly go to the snippets, and if you have any doubts, you can ask me.
Audio தானே?
Yeah, yeah,
What
I could
one
able.
minute?
Yeah, yeah, I can able to hear voice. Yeah, yeah, there is a lot of yeah, Vishwaragul. Yeah, do you have any doubts in electrical machines, particularly in electrical machines? Somebody has to respond because we can able to hold only for the half an hour.
Sure.
Yeah, yeah, Divya, I could able to see your hello.
Yeah, this is only for discussion or taking class.
Yeah, I'm taking discussion also. There can be both discussion as well as class also. Hello. Yeah, I couldn't able to listen to your voices. Yeah, somebody be clear.
Sir, if you have any material right now with you,
Yeah, just wait a minute. I'll just go to my.
Yes.
Yeah, can anybody put your doubts? I hope everybody might have gone through that Google Classroom. In that, particularly in that yesterday session, I have told you that to go for this Google Classroom, and if you have any doubts in Unit 1, I uploaded the video lectures also under Unit 1 and some snippets. If anybody have doubt in Unit 1, yeah, I could not able to hear you. Yeah, hello, yeah. No, I could not. The noise is too heavy for me. Yeah, okay. No, I could not able to hear your voice. Please be clear. No, I could not able to hear you, but your voice is not that much clear. Yeah, I hope that you are all there, but I could not able to listen to you. Only I could able to hear your noises alone. Yeah, can you able to see that word pad?
Yes, sir.
Yeah, okay. This under Unit 1. Yeah, can you able to see that word pad now? I have put your question. Okay, let me put this question first. There is some question called as what is the necessity of a starter? Can anybody tell me what is the necessity of a starter? Yeah, can you able to hear me? Yeah, guys, 24 of you are there, but I could not able to hear that. But so many voices, so many noises are there.
Necessity of
Yeah,
starter.
yeah. Can you able to hear? Yeah, what is the necessity of a starter? Can anybody share your what you have done so far in your class? What is the necessity of a starter? Okay, I will launch a whiteboard. Uh, can you able to see this? Okay, the question is, what is the necessity of a starter? Can anybody see this whiteboard? A line on this? Yeah, guys, I'm asking you, but nobody is responding me.
Yes, sir.
Yes. Okay. Now, what is the necessity of a starter?
To give the initial torque.
Initial torque, no. Actually, the necessity of a starter is whenever if you give a supply directly to a machine, since the armature resistance is very, very low, heavy current will pump into the armature. So, say for example, if you have a DC machine of current rating of around 17 amperes, its armature resistance will be very low, somewhat around 0.2 amperes. If you take V is equal to EG is equal to V minus IARA or EB is equal to V plus IARA, then if you substitute it, if a terminal voltage is around 220 volts, and then armature resistance is 0.2 ohms, then if you happen to calculate the current, it will be somewhat around 10 times of that actual full load current in such a way that it might get burnt up. So in order to avoid the damage to the motor, we are putting the starters. Can you able to get it? There is an equation called
Sir.
as EB. EB is equal to B minus IARA. Okay. Can you able to see this black whiteboard? What I have written there here? EB is equal to B minus IARA. Okay, try to get this answer. EB is equal to B minus IARA. Okay, so you are going to have a back EMF when the motor is not running. The back EMF will be 0. If it is 0, then V is equal to IA into RA. Got that? Now IA will be V divided by RA. Since armature resistance is very, very low and the terminal voltage is around 220 volts, then IA will be of around 220 divided by 0.2. That is, it will be twice of 10 times of that supply current. So it might get damaged. In order to avoid this damage, we are going for something called as the starters. So this is the necessity of a starter. So if you happen to go for a starter, there are 3 types of classifications of starters: 2-point starter, 3-point starter, and 4-point starter. 2-point starter is particularly used for there is no noise, so much of noise. 2-point starter is used for DC series motor. 3-point starter is used for DC shunt motor, and 4-point starter is used for DC compound motors. Yeah, guys, are you all listening?
Yes, sir.
Okay.
Yes, sir.
Okay, fine. Okay, let me go to the second question. What is meant by armature reaction? So I've given you something called as the practice questions. These are the questions that I'm discussing. You know, what is meant by armature reaction? Okay, let me put this answer now. Armature reaction is one where you are going to have a main field flux. Main field flux comes from the poles, and then armature flux that comes from the rotor. Yeah, hello. There are so much of noises. Okay, once again I repeat, what is meant by armature reaction? Armature reaction is the effect of armature flux on main field flux. The resultant will be 2 things. One is called as cross magnetization. The other one is called as demagnetization. Cross magnetization happens on the main field flux. Demagnetization also happens the main field flux. Thereby, the generated EMF will be very, very low. Okay, so this is called as an armature reaction. That is a very, very important question. Okay, fine. The next one, what are the conditions for building up of a shunt generator? I think everybody have done this. What are the conditions for building up of shunt generator? In the first, in the practical session, what you have done in the class, that is lab session. In the lab session, first experiment is you have done something called as open circuit test and the load test on DC shunt generator. In this open circuit test on DC shunt generator, if you happen to increase the field current, okay, from 0 to say for example of around 1.2 amperes, we cannot go up to 1.2 amperes, but it will start from 0 to 1.2 amperes. Then the voltage will start building up. If the voltage starts building up, after reaching to around 220 volts, the voltage gets saturated. Okay, when the voltage is getting saturated, this is due to something called as the residual magnetism, and that is called as saturated voltage. The saturation voltage happens due to something called as, it depends upon the materials you choose. The material you choose is nothing but the electromagnetism that is present inside the motor, or otherwise in a DC machine. Even though if you increase the field current after 1.2 amperes, the generated voltage will not be more than 220 volts. It will be staying there itself as a constant. Got it? Yeah, I'm getting there is some problem with my internet connection. Can you able to get the answer? Okay, in that case, with the help of that open circuit voltage, we can be able to calculate the critical resistance. With the help of the critical resistance, we can be able to find out the shunt resistance. Shunt resistance is 1, that is RSH. We can be able to find out with the help of a multimeter. That RC critical resistance, we can be able to find it from the open circuit characteristics. We can draw a slope. From that slope, del EG by del IF will give you del RC. That is called as a critical resistance. I think this is the thing you might have done in your first experiment in your lab class. So that RC must be greater than RSH. That RC is called as a critical resistance, RSH is called as shunt resistance. RC must be greater than RSH in order to, that is one of the main conditions for building up of shunt generator. The other one is proper connection has to be there for a shunt generator. That is, field terminals and armature terminals must be connected in a proper manner. That is, A1, A2, F1, F2 must be connected properly in such a way that positive terminal is being connected to A1 and then F1. Negative terminal has to be connected to something called as A2 as well as F2. Then the generator voltage will be in the particular order called as plus and minus. Suppose if you happen to reverse that, either the field terminal or the armature terminal, then the generator voltage will be in the opposite order, that is minus and then plus. Got it? This is one of the main condition, important condition we need to know it in the case of a shunt, conditions for building of a shunt generator. Okay. So what will happen if you happen to reverse the terminal of a shunt generator? Anybody can answer this? The question what I am posing you here is, what will happen if you reverse the terminal of either an armature or a field circuit? Yeah, can anybody answer this? Everybody got the question? No? Okay, in that case, what happens is, that is the back EMF, what is the back EMF that is being stored in the generator will get lost. Okay, thereby you can't be able to use a shunt generator itself. This is the main important thing you need to note it whenever you are giving a connection to a shunt generator. That is the polarity and the terminals has to be in that particular order. If it is failed, then there is no condition for building of a shunt generator. Okay, so this is an important topic. That is an important question as well for the conditions for building of a shunt generator. Okay, got it? Fine. The next question, give applications of DC generator. Actually, before going to the applications of DC generator, let us first classify a DC machine. DC machine is being classified into two things. One is called as separately excited. The other one is called as self-excited DC generator. Separately excited DC generator is one where the excitation of the field circuit is given by using a separate DC source. That is called a separated DC generator. Self-excited DC generator is one that has been further classified into three things. One is called as series, shunt, and then the compound. Series I machine called it as a DC machine. So if you happen to use as a generator, it is called a series generator. If you happen to use as a motor, it is called as a series motor. So what is the main difference between a DC motor and a DC generator? Yeah, somebody called as Kirti Vasan. Yeah, you are getting admitted, but please respond. Kindly, anybody respond. What is the difference between a DC machine and a DC generator?
DC generator helps mechanical into electrical.
Yeah, that's good. Mechanical energy to electrical energy is being converted as a DC generator. Okay. Then as a DC motor. DC motor.
Electrical to mechanical.
That's good. Okay. So you got that the basic difference. Now my question is, what is the main classification of a separately excited and a self-excited? What is separately excited DC machine and then self-excited DC machine? No, a separately excited DC machine is one where the field circuit, okay, the field circuit is being excited separately using a DC source. That is called a separately excited. Self-excited is one where you connect it directly to the armature itself. Got it? If you connect it to the armature and also to the supply, then it is called as self-excited DC supply. Okay, that the self-excited one is being classified into three things. That is called as series, shunt, and the compound. Got it? Series is one. The field circuit is being connected in series with the armature winding. Shunt is one. Armature winding is being connected parallelly to the field winding. Compound is one. In compound, we have two types. One is called as short winding. The other one is called as long winding. Okay. Just wait a minute. I need to admit another again. Okay. Please identify yourself, but your names is not getting listed. Okay. Let us start. Okay. In the case of a series motor, a series generator will always be used for traction purposes, because it can, one thing, as a DC series generator, it can be able to develop a large amount of current. Okay. Because it is I square. It is I square times of it. So it is, that is why there is DC series generators are used for traction. DC shunt generator is being used for charging of car batteries, since it can be able to generate a constant voltage. Since it can be able to give it the constant voltage, it is used for these charging of car batteries. In the case of compound generators, this compound generators is being used for two purposes. One is as a long shunt, the other one is called as a short shunt. Long shunt is also called as, anybody? Long shunt is also called as cumulative. Short shunt is also called as differential. Okay. Long shunt is being used for arc welding. Okay, we can use for arc welding, that is for long shunt generators. Short shunt, others called as differentially compound generators, is not that much widely used. Okay, these are the applications of DC generators. Okay, now what can be the applications of DC motors? Anybody?
Railways.
Don't tell me particularly in railways. DC series motor is used for railways. Why? Why DC series motor is used for railways? Anybody? Because the torque is proportional to some,
more torque.
Yeah, no, it produces more torque. That is one of the answer. How it produces more torque? That is one equation for that. Torque is proportional to K times of Ia square. Got it? Because at the time of starting of a DC or any train, you need to have a high torque. In order to have a high torque, okay, you need to have a high torque. You need to use only a DC series motor, because torque T is proportional to Ia square. That is why DC series motor is used for traction. Then what are the applications of DC shunt motor? Anybody? Yeah, DC shunt motor. Yeah, Hariharan, I think you are getting highlighted. Hariharan, only I could be able to see you, but not the others.
Sir,
Yeah, what are the applications of DC shunt motor?
it is used in constant field applications.
Yeah, why? How it has been used for constant speed applications? In the case of DC series motor, torque is proportional to Ia square. Whereas in the case of DC shunt motor, T is equal to ISH alone. That is, Ia is equal to I minus ISH, only Ia alone. Because their supply voltage is being directly proportional to the shunt current. That is, once again, it has been, just a minute, it has been directly proportional to the armature current. That is why supply current is always constant in the case of DC shunt motor. That is why DC shunt motor is used for constant speed applications. Constant speed applications, anybody? What are the applications of constant speed? Applications of constant speed? There are so many of them are there. The main important thing is for DC shunt motor is it is being used in lathes. Okay, particularly in lathes where you need a constant speed, there DC shunt motor is being used. Okay, fine. Then let us come to about something called as losses. What are the types of losses that are available in DC machines? What are the
Copper
losses?
loss.
Okay, copper losses. Okay. And then
Iron loss.
Yeah, very good. Iron loss, copper loss, and then one more important thing is there. That is nothing but the mechanical loss. Okay, the losses that are there in the case of any DC machine is these three things. One is called as a copper loss, the other one is called as mechanical loss, the other one is called as iron loss. So what are the copper losses are? What are the copper losses?
Mysterious process.
Okay, no. Iron loss comes under hysteresis loss. I'm asking about copper loss. Yeah, copper loss.
Armature copper loss and
Yes,
field copper
yeah,
loss.
very good. Armature copper loss and then field copper loss. That's a very good answer. Apart from this, any other loss? Only these things? Okay, in the case of a compound generator,
Mechanical.
you'll be having, I'm talking about only copper loss. In the case of copper losses, you have armature copper loss, you have field copper loss. In the case of compound motors or compound DC machine, you'll be having both these two. Got this? This is about copper loss. In the case of iron losses, you are going to have hysteresis loss as well as eddy current loss. Now, what is hysteresis loss and what is eddy current loss? What is hysteresis loss and what is eddy current loss? Okay, hysteresis loss is one where you are going to have that is something called as frequent reversal of magnetism. That is, whenever the armature rotates, one part will be under north pole, the other part will be going to the south pole. Whenever there is a frequent reversal of magnetism, then you are going to have something called as hysteresis loss. That is charging up and charging down. Okay, this type of losses is called as hysteresis loss. Then eddy current loss, it entirely depends upon the volume of the core. Okay, so whenever the volume of the core, or otherwise the size of a DC machine, these losses can only be minimized. These losses can only be minimized, but it cannot be neglected. So eddy current loss and hysteresis loss will always be there. Okay. If you happen to talk about in the case of transformers, hysteresis losses will not be there. Only eddy current loss will be there. We can able to minimize eddy current loss by having proper laminations. If you have a proper lamination, then we can have an hysteresis loss minimally. Got it? So whereas in the case of eddy current loss, hysteresis loss, we can able to only minimize it. That is one thing. Mechanical losses are one. There are nothing but wear and tear loss. Okay, wear and tear loss are called as mechanical losses. That mechanical losses happens whenever there is a rotation. That rotation happens due to something called as the armature rotates, the rotor rotates, the stationary part is there. Before that, one thing, what is there in the stator, what is there in the rotor of any particular DC machine? Can anybody answer? What is going to be there in the stator and what is going to be there in the rotor? Yeah. Yeah, Divya madam, sorry. Yeah, there is due to something called as stator connection.
Magnetic poles.
Yeah, in the case of a DC machine, in the stator, you're going to have magnetic pole. That's a good answer. How about in the rotor? Rotor of a DC machine. Rotor of a DC machine.
Armatures.
Yes.
Armature.
Yes, armature. Apart from armature, what else it's going to be there in the case of a DC machine? Apart from armature, you are going to have commutator. Yeah, that's good. Yeah, that's good. That is, you are going to have commutator. You are going to have brushes. Now, what is the main purpose of commutator? What is the main purpose of commutator?
Converts AC to DC.
Yeah, that's good. It converts AC to DC. Now, that is not the only purposes. It collects current from all the windings. That windings is being
armature and
to the external circuit. That is also good. Okay. How it connects? The armature windings. That armature windings can be of two types. One is called as a lap winding. The other one is called as a wave winding. Okay. Those two are being connected. From that, it converts AC to DC. That is the main feature of a commutator. After from commutator, what else is there? That is nothing but the brushes. That brushes is one which has been connected to the external circuit. Okay. Okay, guys. I think this 40-minute has been got it. Okay, we'll be joining once again on Saturday. Yeah, I think it is getting closed. I think so. Once again, those who are all there, please once again I'll post it once again in your group. So do kindly join through that. Once again, we'll be having a session on Saturday. Before that, I'll upload some of the materials. Kindly go to the materials and we'll have a discussion format. Okay, but do participate in. But since this is the first time, this is the first class, but I would be able to see only 24 participants are there, but they are not in active mode. Okay, so do kindly join me on Saturday. I'll post you regularly. Okay. Sorry, yeah, Nagajodi. Yeah, I could be able to see that you are raising your hand, but yeah, Nagajodi, please. Yeah, I could be able to. Nagajodi, please put your question. No, I would not be able to hear you. Gone? Yeah, anybody there? Yeah, I think it's time. I think so. Yeah. Okay, I'll post you updated on your group. Please kindly once I come and join me on Saturday. Okay. Thank you.